Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in the previous video we discussed what is non-linear recursion, and also we solved two previous problems, how overlapping problems occurs in non-linear recursion which are being solved using the DP concept. Now in this video we'll solve the next question, which is unique path. This will come under DP category, but definitely we'll practice one more question from this category, which is non-linear recursion. So if you read the problem, it says ki there is a grid and you have to start from 0 cell and you have to go to the last cell. You have to say ki how many different ways are there. Similarly, we have solved the previous question, which is climbing stairs, where instead of counting the number of jumps, we have to answer ki how many ways are there to reach nth step, correct? So this is a similar question. If you read the constraint, it says m and n both can be equal to 1 or 100. So when row and column both will become 100 means for sure the number of cell will become 10 power 4. How I did? 10 power 2 multiplied by 10 power 2, correct? So 10 power 4. So definitely if we will write the recursive code for this 10 power 4, beyond 30, the time complexity of this code will become 2 power 30, and beyond that it will give us TLE, correct? So for sure 2 power 10,000 is not possible, and hence we have to optimize using the DP concept, definitely. Okay, so let's try to understand the problem and let's try to build the logic also. So we have to start from this cell, okay? We have to start from this cell and we have to reach here. We have to say how many ways are there. Forget about this bigger grid. Let's start with this because it says number of row and column can be 1 also. So you tell me, if I am here and I have to reach here, how many ways are there? So definitely we are standing here and we have to reach here. How many ways are there? Definitely we will not move. So there is one way to reach the cell, which is don't move. Can I say that? Yes. Now think about what if we have cell like this. So we are standing at here and we have to reach here. How many ways are there? Only one, which is take one jump. Can I say? Now think about this. I am standing here, I have to go here. Correctly? One way. This is so very easy. Now think about 2, 2. I am here and I have to reach here. There are two ways, which is, remember, diagonal movement is not allowed. So definitely I'll go here and I'll come here one way, and I'll go here and come here two ways. So two ways are there now. So it is not asking how many jumps you are taking, how many turns you are making. No, it is just asking how many ways. You can consider that how many paths are there. Okay, kind of that. Yes. So I know one thing, ki if I have to reach here, I will come from here, I'll come from here. So can I say two? Can I say one thing? Ki if I am here, like I saw na for 1, I found 1. Okay, for 1. Now I also saw ki from here to here I have to go, there is only one way. So to reach here also there is only one way. Now I also saw from here to here to reach there is only one way, so definitely 1. And I saw to reach here we have two ways, this way and this way. So can I say 2? So can I fill this also? 1, 1, 1, 2. Okay. Don't get confused. Just try to understand. What if there are this, like this is the only diagram you have and you have to reach the last cell. Can I say there is only one way? Again, don't take 2 jumps. No. Way. How many paths are there? Only one path. Correct. Similarly, what if the size will become 4? Still only one path. Size will become 5. Still only one path. Means if you are starting from this cell, how many ways are there to go to this cell? Only one way, na? Move straight. Correct. So hence, I can say for my row 0, the number of ways will be only 1. Similarly, I can say for my column 0, the number of ways are only 1. So I will fill this. Correct. Now if I have 2, what is this 2? Like this, so 2. Okay, forget about any, like you are not able to come up with any formula, so I'm just breaking this down for you. Okay, now let's consider for this cell. Okay, let's count. Okay, forget about the rest. So how many ways are there? So first way is this. Can I say? Okay. Second way is this. Can I say? Yes. And third way is left, down and left. Now don't think about ki 3 prugana. So only 3 ways are there. Why? Because if you see here na, like you can only move down. As you can see, the robot can only move either down or right at any point in time. So you can either move down or you can either move right. Like once you moved ahead, you cannot come down and move left. No, you cannot. This is not allowed. Okay. So hence, by following the rule, there is only 3 paths. One path, left, right, 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 down. Second path, down, right, right. And third path, right, down, right. Okay. So I did 3. Okay. So don't you think this is following some formula? Is like for this you solved 1 plus 1 2. For this 2 plus 1 3. Similarly for this 3 plus 1 4, it will become 4. If you still want to check, let's check that. How many ways are there? Right, 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 down, one way. Down, right, right, right. 2 ways are there. Second way is right, down, right, right, 3. Fourth is right, right, down, right. Correct? So 4 ways are there. So hence for any cell, the answer is summation of above and left. So like, can I say up and left, which is nothing but for any row and column, I want row minus 1 column and row column minus 1. Yes. So in the code, basically we have to say if my row, like which I am looking for, is equal to 0. Like if I am looking for any term which is at 0th row, or if I am looking for any cell which is at 0th column. So I can say if row is equal to 0, or if column is equal to 0, correct? I can say simply return 1, because that is the answer, correct? Or else what can I do? Suppose for this cell, if it is asking. So definitely for this cell, we cannot directly return this plus this, because initially it will be empty, right? So for this cell, you have to start from this one and start filling all this and then come here. So if it is about recursion, there is no extra space you are using. The only extra space you are taking is because of the recursion, your all function calls are getting saved in the stack. That is taking extra space complexity, but you are not taking any extra space from your own side to save your answer. Okay. So this is a grid I just showed you how it will look like. So for this term, if I am asking for this term, the input, as you can see, you will be given m and n. M and n is nothing but row and column I am considering. So here you can say if m is equal to 0, or if n is equal to 0. You can simply return 1. Or else if you are talking about any cell, correct? So the thing is, if you want this cell, okay, and you don't have any pre-calculated answer, correct? So if you want for this cell, you will say I want this and I want this summation to give you the answer. Now this cell will say I want this and I want this, and this will say I want this and I want this. Again this will say I want this. Are you getting this? So basically, apart from this, you have to return the same function. Let's say this is a function where you are getting m and n. So the same function m minus 1 and n plus same function m and n minus 1. That's it. That is only recursive code you have to write. But talking about the time complexity, as you can see, there are 2 functions getting called in the single iteration, correct? So can I say for every node you are calling 2 functions, so 2 nodes will become. Again, for every node 2, for every node 2. So the stack calls will not be linear anymore, it will be non-linear. Okay, so that is the reason it is categorized in the non-linear recursion. Second thing is, because of this, overlapping subproblems might occur. For sure it will occur. Okay, so as overlapping subproblems can be there, definitely we have to, like to optimize, we have to save the pre-calculated answer, so that next time if we will reach to the same input value, we need not to recalculate it, correct? So definitely to optimize it, you have to use the DP concept. But as currently the time complexity is 2 power n, and as n is nothing but m into n, means number of rows into column. Number of row and column are 100 cross 100, so total it will become 10 power 4, means 2 power 10 power 4. Definitely it will give us daily, and we have to optimize this. Because of that we use a DP concept. But because we are focusing on non-linear recursion, so let's write the code for this and then we will optimize it. So first we will make a function, return type will be int, let's name it count paths, okay, and we will send the row and column to it, int column. Now inside this we have to write the base case ki what if row is equal to 0 or column is equal to 0. If so, we have to simply return 1, correct? Otherwise we have to call the same function return count path, and in this we have to do row minus 1 column, and once again row and column minus 1, correct? This is what we have to return. Now in the main function we will call the function count paths with row which is whatever is m minus 1 and column n minus 1. Why? Because it is zero based indexing, right? So that's why. Now let's run the code and let's try to submit this. Okay, you will see that it will give us TLE because of the time constraint, which is 2 power n. Yes, as expected. So we have to optimize it, correct? I hope you understood the reason behind this. Okay, so if you understood, this was your Java code and here is your Python code with a similar approach, and here is your C++ code with a similar approach if you are from Python or C++ background. But this code has not been submitted. The only reason we solve like this is to understand what is nonlinear recursion. And you know, in nonlinear recursion there are high chances कि overlapping subproblems can occur and you have to save the answer. So definitely the another way is, as I shown you this grid, you can make a grid or matrix of size m cross n, correct? And how you were solving, like how you are calling these functions, correct? So for whatever cell you are getting, you will keep on saving the answer here, correct? So that in future, like suppose for this you will call this and this, correct? Now this will call this function and this function, okay? Now once it will go and calculate and recover its answer, this cell will also go to left and up. So for up it is valid, but for left, why it is going to recalculate? This was already calculated by this cell, correct? So that if you would have saved it, you can simply, instead of like for this, instead of calling this cell to calculate the answer, you could have directly used the pre-calculated answer. So hence in this way it will reduce the time complexity, correct? So that is the only idea, कि whatever call we will make, whatever the answer we are getting, instead of returning directly to the function back, we will first save at that index of mn and then only we will return. So let me write that code. That is what called memoized code. Okay. So the only difference in the code is कि we will define a 2D matrix here. Let's name it dp is equal to new int of size m and size n. Okay. Once done, here in the base, like here will come first. So in the function also we have to mention dp. So int dp, and here also in the call we have to send dp. Now after checking the base case, instead of directly calling the function, we have to check what if it is already calculated. So if it is already calculated, then dp of row and column value cannot be equal to 0, because initially it was initialized with 0, so it cannot be equal to. And if it is not equal to, instead of calling the recursive function, we will save whatever answer is saved there, which is dp of row and column. But this we have to save also. Where can we save? Here. So before returning, we will save in our dp of row and column. Once we save it, we can return dp of row and column. Done. And now let's try to run the code, and definitely here all those overlapping sub problems are getting solved. Did I miss anything? Okay, my bad. In the function also we have to send dp, right? Correct. Now I think it's correct. Now let's run the code, and definitely it's passed, and when we'll submit this, it will get passed, because the time complexity is now O of n into m. Why? Because now whatever code we are writing now, we have memoized it, and like for any function we are only going back to the previous ones, because the previous cell have already calculated and saved their answer in that dp of row and column. So we need not to go in the recursive ones. Okay, so this is what called memoized code, or that's what dp is. Okay, so I hope you understood. If yes, then here is your Python code with the similar approach, and here is your C++ code with the similar approach if you are from Python or C++ background. So I hope now you clearly understood what is nonlinear recursion, and we have already solved 3 different problems on it, and how overlapping subproblems causes the use of DP concept or memoization. Okay, so with this thought, I want to mark the third question also from this pattern, and I hope you all will solve this on your own and also mark this code. Now the next question, which is house rubber, I hope you already understood what is nonlinear recursion and how in nonlinear we use DP concept. So this problem we will solve in our DP playlist. So as of now we are done with this pattern as well, and now in the next video we will cover what is divide and conquer pattern, and we will solve few questions from that. Okay, So with this, let's wind up the session, and if you have any doubt, please do let me know in the comment section, or you can even reach out to me on Instagram and LinkedIn. I'm very active there. All the social media links and the sheet link you will get from the description. And that's it. Let's meet in another video with some more interesting topics and questions. Till then, keep learning, take care of yourself and your family.